Question number 21. A carbon resistor has color bands as shown in the figure its resistance. And we know that in this type of question you can use carbon color code BB like that. R is equal to AB into 10 to the power C plus minus D means tolerance. A first significant, B second significant into 10 to power. So this is 1 A, this is B, and that will red color will give you the power of 10, and this will represent the tolerance. So if I go for the carbon color code, A 4, B 1, and for the red power will be 2, and in the gold tolerance will be 5%. So when I will convert this value in kilo ohm, then you will write 4.1 kilo ohm plus minus 5%. So this is a basic question. So my option number 1 will be the right choice. Let's move on. Question number 22. In the question number 22, in the circuit shown in the figure, reading of ammeter is I1 when S1 is closed. Okay. Reading of ammeter I2 when S2 is closed, and reading is I3 when S1 and S2 both are closed. Okay. So first, if S1 is closed, then if I go for current I1, I need potential and equivalent resistance. When S1 is closed, then 3R and 2R will be effective and both are in series. So resistance will be 5R. This is relation number 1. And now similarly, when S2 is closed, then 6R and 2R will be effective. So value of I2 will be V upon 8R. This is my relation number 2. And when S1 and S2 both are closed, then 3R 6 will be in parallel. So 3 into 6, 3 plus 6 means 2 ohm. 2 ohm, and this 2 ohm will becomes in series. So finally you will get I3 V upon 4R. So this is the relation number 3rd. By this relation I1, I2, I3, you can see 1 upon 5, 1 upon 8 and 1 upon 4. So we can easily find out I3 is greater than I1, I1 is greater than I2. So this is the final relation. So I can say my option number 3rd will be the right choice. Let's move on. Question number 23. In the question number 23, an electric current 6 ampere flow a conducting wire of length 3.2 meter. The total linear momentum of the electron's wire is approximately. Okay. We know the total momentum means mass of electron and drift velocity of electron, because electron is moving with drift velocity. For total momentum, we can multiply it with N. And the current I is given by NEAVD, where A is the area of cross section, D is the drift velocity. So I am looking to find the total momentum. So NMEVD. For your simplicity, if I multiplied with EAL, numerator and denominator both, then I am looking to make this relation. So first I will write NEAVD upon E, the remaining term ME and L. You can replace this value by the current. So you will get a very good formula, I upon E, ME into L. Now all values you know. So you will put I6, mass of electron 9.1, 10 to the power minus 31, and length 3.2, divided by the fundamental charge 1.6, 10 to the power minus 19. So when you will calculate, will get 1.1, 10 to the power minus 10 kg meter per second. So this is how you can solve. On further, in future, you can memorize this relation. So question number 23, option number 2 will be the right choice. Let's move on. Question number 24. In the question number 24, a battery EMF E, internal resistance R is connected across a load resistance RL. The plot between output power and load resistance. Okay, this and this. The value of EMF, internal resistance are respectively. So question is asking to us EMF E and internal resistance. So you can solve easily. You know the maximum power theorem. square upon 4 times of load resistance, and with the condition internal resistance will be equal to external resistance. So if I go for the graph, then you can observe the maximum power will be 50 and load resistance will be 2, and this is equal with the internal resistance. So if I use this relation, I can write EMF is equal to under root 4 times of load resistance and maximum power. So now I will use this relation. 4 into load resistance will be 2, maximum power will be 50. So on solving we'll get 20 volt EMF. And in the case of internal resistance, as I discussed, this is equal to the external load resistance. So by this calculation I can say my option number 1 will be the right choice. So let's move on question number 25. Question number 25. The resistance of the 4 arms A, B, C and D of wheatstone as shown in the figure 10, 20, 30, 60 respectively. The EMF and internal resistance of the cells are 15 and 2.5 ohm respectively. If the galvanometer resistance is 80 ohm, then net current drawn from the cell will be. So A is 10, B is 20, C is 30 and this is 60. So if I check 10 by 20 and 30 by 60, then we can say this is a wheatstone bridge and balanced wheatstone bridge. So 10, 20 are in series, 30 and 60 are in series, and so 10, 20 will be 30 and 30 plus 60 will be 90, and after that they are in parallel. So if I consider this is a point P and this is a point Q, and if I go the net resistance between PQ, then we'll write 30 into 90 and 30 plus 90 according to the wheatstone bridge. So we'll get 45 upon 2 ohm. So this is the equivalent resistance. And if I go for the current we need potential V, net resistance external plus internal. Potential is 15, external resistance 45 by 2, internal resistance 2.5 means we can write 5 by 2. So on solving you will get 15 upon 25 or 0.6 ampere. So this is the current. So by this calculation I can say my option number 2 will be the right choice. Let's move on question number 26.